Hey guys, it's Mr. Dorado here. Just wanted to make a quick video for you guys on the first section of our Chapter 1 unit. So we want to go ahead and get started right away and try to see if we can reach our objective. We want to be able to simplify expressions by combining like terms and by the distributive property. So that's our main goal for today. So in order to do that, we have to figure out a few things. We have to first be able to identify what all of these words at the top of our page are: an expression, a term, or a coefficient. Okay, so right away, right off the bat, we see this 3x squared plus 7x plus 2. Now, a lot of you guys might be thinking, oh, that's just an equation. Well, not quite. If you guys look at it a little in more detail, you'll notice that there is no equal sign. Hence, it can't be an equation. Okay, this is separated by plus signs here, and it's separating it into exactly 3 terms. Okay, so that's what our terms are. So let's go ahead and write some of those down. So we have 3 squared, comma 7x, and also a positive 2. Okay, and we're going to go ahead and do the same thing for the rest of these expressions and figure out how many terms we have, and then eventually how many or what the coefficients of each of those terms are. So let's go ahead and write these down. So we have negative 9m squared, comma, whoops, sorry about that. Still getting used to this pen mechanism. So that's 8m, parentheses, comma, negative 1. Okay, let's keep going. So let me actually move this comma over here. Okay. All right, so we have 2 to the third, comma, negative 9x, comma, positive 11. Okay, let's keep going. We have a negative 4y, comma, negative 13. Next one we have a 6, comma, negative 5n, comma, negative n squared. All right, and then for this last one we have x. We have a negative 3, a 2y squared, and a negative 5y. All right. So, in order to figure out what our coefficients are, we have to look at each of these terms we have in each one of our expressions. Okay? Well, a coefficient, by definition, is the number that is in front of any term which has a variable in it. Okay, so in this case, for our first expression, we have the term 3x squared. So our coefficient here is 3. We have a coefficient of 3. Okay, we also have a coefficient here of 7 for our next term. And if you notice, there is no x next to the 2, so we don't have a third coefficient. Okay, now to make that a little more clear, let's keep going. So for the next expression, we have negative 9 as our coefficient. We have an 8. And then finally, once again, we have a negative 1. Okay, but this negative 1 does not have a variable attached to it, so it's not a coefficient. Okay, let's keep going. So next one, 2, comma, negative 9. Once again, 11, no coefficient. Next one is just negative 4. That's the only one with a variable. Next one, we have a negative 5. We didn't write that 6 because it doesn't have a variable attached to it. And in this one, even though you don't see it, there is a 1 in front of that negative. Okay, I'm sorry, behind that negative. So right in front of that n. So we actually have a coefficient of negative 1. Again, if you would like to see that, it's right there. Okay, so let's keep going. Next thing, we have a coefficient in front of the x, which is a 1. Okay, that negative 3 doesn't have a variable, so it's not a coefficient. Next one is a 2. And the next one is a negative 5. Okay, so again, we just went ahead and figured out what an expression is, a term is, and a coefficient is. Okay, now to kind of get you guys going here and having you guys understand on a more deeper level the topics that are going to be coming up, I actually want to break this down even further and talk about the number of terms that I have in each one of these expressions. So for this first term, for this first expression, we said we had 1, 2, 3 terms. Okay, again, 1, 2, 3 terms. All right, now what we call that, or actually I'm going to go ahead and write that down first. So we have 3 terms. I'm just going to write that here off to the side. Okay, so in this next one, again, I have 1, 2, 3, or as we wrote them down here already, 1, 2, 3 terms. So this is yet again a 3-term expression. Next one looks like it's the same. This next one here only has 2 terms. Following one also has 3 terms, and this last one has actually 4 terms. Okay. All right. So the reason why I wanted to go further into that is because these right here, 3 terms, 3 terms, 3 terms, 3 terms, those have, and if you want to write it down right up here, those have a special name. Those are called trinomials. Okay, so if you guys hear me say some of that later on in this chapter, you'll know exactly what I'm talking about. So again, 3 terms, those are called trinomials. Now we have something like this that only has 2 terms. Some of you guys might already know it, but this is called a, whoops, that's not what it's called. Go back up here. This is actually called a binomial. Okay, so that is called a binomial. All right, this is the one that maybe you guys don't quite remember, but it's okay because again, we're going to review it today. This last one here with 4 terms is what we can call a polynomial. Okay, again, this is a polynomial. Anything with 4 terms or more is considered a polynomial. Okay, all right, so even further into that, we want to go ahead and, or I want to actually go ahead and start by defining what these terms are here. I'm going to go ahead and circle them. As you guys notice, I mentioned that these aren't coefficients. These are just numbers because they don't have a variable next to them. Okay, so all those numbers here in blue, those are actually called, if I can get this pen working, not so much. Sorry about that, guys. Those are called constants. Okay, so this one right here, this one right here, all of these terms are called constants. They have no variable next to them. Okay, now it's important to define those things because in the next bit, so when we're actually simplifying expressions, we actually have to know what we have to combine. Okay, so that brings me to simplifying expressions. So we're going to go ahead and write this down. So our first step to simplifying expressions is to combine like terms. Okay, so we have to combine like terms in order to simplify an expression. All right, and in order to do that, we have to be able to identify a few things. We have to have terms that have the same variable and degree. or another way to say degree is exponent. All right. And once we have those terms, when we know what those terms are, we have to actually go ahead and add or subtract their coefficients. So we want to be able to combine like terms, but what does that mean? All that means is that the terms have to be the same variable and have the same degree, okay? And they also have to add and subtract their coefficients for when we're actually combining those terms. All right, so let's actually go ahead and check what things we can combine in this example. So right off the bat, I see something with an x squared term and another x squared term over here, okay? So remember, what coefficient's in front of this? It's a 1. So when we combine those two, we have 3x squared plus 1x squared. That's actually 4x squared. Okay, those are now done. I've used those up. Now I have to check for another type of like term. So we have that 2x and the negative 6x. If I combine those once again, that is a negative 4x. And finally, we have these constants. Remember we talked about constants? We have those constants, and those are a negative 5 minus 7. That gives me a negative 12. So I have officially combined my like terms. All right. So let's go ahead and continue with this and get some more practice. All right. So again, let's check for like terms. The only thing that I see similar here are constants. Everything else is different. This has, whoops, sorry about that. This has 1x here, and this has 2 x's there. So we have 2 blue ones, 1 green one, and 1 pink one, or purple. So what I want to do is actually combine that largest one first, so that 5x squared. Then I have a negative 3x. And then that 6 plus 7, which gives me a positive 13. Okay. Now this form right here has a special name that I'll come back to in just a second, but let's continue on with our 2 examples, and then I'm going to have you guys try out that last one on your own. All right, so I understand you guys might not have highlighters like I do, so I'm going to go ahead and show you how you can do it on your paper using just your pencil. Okay, so again, let's figure out some like terms here. So we have a 4x and a negative 9x, so just go ahead and underline it with one line. All right, so I'm going to go ahead and combine those. That gives me a negative 5x. Next one you see here is a, oops, we have 6y and a y. I'm going to actually put those in a box. All right, so again, the coefficient here in front of this y is a 1. So I'm going to go ahead and write it down. So that's 6y plus 1y gives me 7y. All right, next one. We can use circles if we wanted to. So we have that negative 2, and actually we can't combine that with anything else. So we're going to go ahead and just write a minus 2. Okay, so that is our answer. I'm going to go ahead and circle that. And we can continue on to the next one. Again, you don't have to use the circle, you don't have to use the square, you don't have to use just one line. You could do whichever method you want. Some people like to use 2 lines. So for example here, they see an x squared there, they see an x squared there. So we see a 6 minus 2, that's a 4x squared. Next one we see our y's. Actually, I see another x. I'm going to go ahead and take care of that one first. So I'm just going to put one line under that one, so plus 7x. And then, if I wanted to, I can actually do 3 lines for these. So again, it all depends on how you want to sort them, how you want to make sure you keep track of all your terms. But in this case, I just use lines, so you can always do that too, or you can do circles and squares like I did before. All right, so let's combine that last one. So that's negative 3y plus 5y. That's a positive 2y. All right. So what I want you guys to do for now is pause the video for a second and go ahead and try out number 4 on your own, and then I'll go ahead and do it together with you guys. Okay, go ahead. All right, guys. So at this point, you should have your answer down on your paper. So let's go ahead and make sure we did this correctly. So right off the bat, I see these w squares that I'm going to combine. So that gives me 8 plus 11. That's a 19w squared. Next ones I see are 2w and the negative 12w. So 2 minus 12, that's a negative 10 with a w attached. And then this last term here is just a negative 5. So that's what you should have gotten for your answer. 19w squared minus 10w minus 5. All right, so let's go ahead and actually what I want to do is come back to this for 1 second. I mentioned this right here was a special form, right? This is what's called standard form. Okay. All right. But what is standard form? What does that even mean? Standard forms is just terms in order from highest exponent to smallest exponent. And that usually means that the constant is the last term. Okay, so let's go ahead and look at this example that we have here. So this is our example that we want to take a look at. So let's go ahead and see what we got. Well, I have a 2x, I have a 3x squared, and I have a minus 5. Now, right away off the bat, I can see that the highest exponent is the 3x squared. That's the reason why we put that first. Okay, the next one that I see that has the highest exponent, again, because even if you don't see it, there's really a little 1 in front of this x. So that is the next term that I'm going to put in my new form, my new standard form. And then finally, just like I mentioned right down here, the last term is usually going to be your constant because that one doesn't have an exponent attached to it. Okay, so that is my last term. So finally, this here is officially in standard form. All right, so again, hopefully that made sense to you guys. If it did not click just yet, it's okay. We're going to do a few more examples and I'm sure you guys will start to get the hang of this. All right. So the next one, we're being asked to write the following in standard form. So let's go ahead and do that. We know we have to go straight to the first, or actually the highest exponent, and right away I can see that the highest exponent here is that negative x to the fourth. So I'm going to write that down first. Negative x to the fourth. So I'm going to go ahead and get rid of that because I already wrote it down. The next one I have is this negative 4x to the third. Again, I'm done with it. Already wrote it down, so I'm going to cross it out. Next one I see here is the 5x squared. Same thing. We used it up, so we cross it out. Next one I see is that plus 7x. And finally, just like I mentioned before, it's usually that constant that comes last. All right, cool. Next one. Highest term, negative 3m squared. Next one, negative 4m to the fifth. It's a positive 11m to the third. Plus 5m. And finally, my constant with no variable, which is that plus 2. Okay. Hope you guys are getting the hang of this. I'm just going to do one more before I let you guys try this last one on your own. All right. So right off the bat, I see here 8p to the fourth, a positive 15p to the third, and finally my negative 6p. Now in this case, we didn't have a constant as our last term, but that's because there was no constant in the original expression. All right. So what I want you guys to do now is try number 8 on your own. Go ahead and pause the video and try that out. All right. So let's go ahead and combine this real quick. All right. So what do you guys think of my work? Did I do this right away? The biggest exponent I see is that 6, so I got rid of that one. Next one is my positive 21a to the fourth. Next one, my positive 42a to the third, and finally that negative 84a. All right, so I think we're starting to get the hang of this. At least I hope so. I sincerely hope so. If you don't understand this, make sure you write yourself a little bit of a note onto the side so you can ask on how to solve these problems, so we can definitely help you out with that. All right. So for number 9 through 12, we want to simplify each expression and write the final answer in standard form. So my recommendation to you guys here is to look for your highest exponent, okay, and then combine all the terms that have that exponent. So I'm going to use the highlighter just because I think it's much easier for you guys to see. But again, you guys can underline them if you feel that that is a good way of helping you guys sort these out. All right. So again, the highest exponent I saw here was these x's. They all have x's here, the ones that I highlighted, and everything else actually is a constant. So I'm going to go ahead and combine all my x's. So I have 9 plus 3, that's 12. 12 minus 5 is a 7x. Finally, I have that negative 10 plus 5, that's a negative 5. Negative 5 minus 2 is a negative 7. All right. Good. All right, next one. I'm going to go ahead and see the biggest one that I have there, which is the 2m squared. Then I have a few m's here. And then finally, a constant. So again, let's combine these up. So first one is the 2m squared. Next, I see the m's. It's 4 plus 8. That's 12 minus 1m. So that's a positive 11m. And finally, my constant, a negative 5. All right. So, whoops. Not sure why that's happening, but let's keep going. So, next one. Sorry, guys. I'm still trying to get used to this new laptop here. Seem to be having some issues with it, but hopefully we can get through this lesson. All right. So, I see my first two terms there that are the highest, or that have the highest exponent. And I'm going in decreasing order because I want to write this in standard form. All right, so biggest one I see is the 3n squared plus 6n squared, so that's a 9n squared. Negative 7n minus 4n is a negative 11n. And finally, I see this plus 2, that goes at the very end. And as I said, it's usually your constant that goes at the very end. All right, so once again, pause the video for a second and try this problem number 12 out and see how you do. Alright guys, so let's go ahead and do a little bit of highlighting here. So, highest exponent, I see this 3 on my y to the third. So 4y to the third minus 5y to the third is actually a negative 1y to the third. Next ones I see is this y squared. That doesn't combine with anything because nothing else matches, so I'm going to go ahead and rewrite it. And finally, I see this negative 11 and this positive 8. If I combine those, I get negative 3. Alright, cool. So hopefully you got the same answer and we can move on from there. Now, this is basically the last part of this section that I need to show you guys, and that is essentially distributing. Okay? Now, we are used to seeing multiplication in different ways. Now, you guys have seen it as a little x or a little times symbol. Another way you've seen it is with a little dot. Okay, I'm sure a lot of you guys remember seeing that. But then there's also sometimes when you see parentheses. Okay, that also signifies multiplication. So when we see this 5 in parentheses next to this x in parentheses, that basically is telling us we have to multiply those two terms. Okay, now, whoops. If you want to think about it this way, you can also think of it like this. There's a little tiny dot right there. Okay? There's a little dot between the 5 and the x, so we're going to have to multiply them out. So that's just a 5x. Simple enough, right? Alright, so let's keep going. Same thing here. There's a little dot here between those two parentheses. Negative 4 times 7, that's a negative 28. But we have an x, so I have to write that one down. Same thing here. 3 times x times 6, well, the 3 and the 6 can multiply, so that's an 18. And then finally, I have my x. And then finally, 9 times 3, that's 27, with an x at the end. So again, that's what we do to simplify this, to actually multiply them out. Now, when we actually talk about distributing, we actually look at taking one term and distributing, just like the word says, distributing it among the other two terms. So what I want to do is actually distribute it to both of those terms. So I want to do 4 times 2x, which is 8x, and then I want to do 4 times 3, which is 12. Okay? All right. So same thing here. Let's go ahead and do this next one. I want to distribute this 2 to both terms. So I'm going to send it to the x and to the negative 3. So 2 times x is 2x. 2 times negative 3 is a negative 6. So now you have two examples there on how to distribute. And remember this little note up here. Distribution is multiplication. That's essentially what we're doing this entire time. Okay. So let's go ahead and put that to practice a little bit and do 13 through 16 together, and then I'm going to let you do 17 through 20 on your own. Alright, so distribute that in here. We get 8x plus 72. 5 times m is 5m minus 30. Okay. Negative 4 times a is a negative 4a. Negative 4 times 9 is a negative 36. And here is a little bit different. But remember, guys, whenever we have something like this, we have a negative in front of there. So if I'm actually distributing, sorry about that, guys. I'm actually distributing this negative 1 to both of those terms. So negative 3b squared. Negative 1 times the negative 9 is a positive 9. All right. Cool. So let's go ahead and have you guys try out these next 4 on your own. So pause the video for a second and then go ahead and check your answers once you're done. All right, let's go ahead and take a look at these. So let's go ahead and distribute this out. So we have 3x plus 24. Let's distribute this. Now we're distributing it 3 times, which is okay. It's not any more difficult than it looks. So let's go ahead and multiply it out. So negative 3 times 5 is a negative 18x squared. Negative 3 times x is a negative 3x. Negative 3 times negative 6 is a positive 18. Next one. Negative 6 times 5 is a negative 30x. Negative 6 times negative 4 is a positive 24. Again, we distribute this negative 1 to both of those terms, so we get a negative 9x plus 3. All right. So these are the 4 answers that you should have gotten. If you did not get those, make sure you double check your work and make sure you understand it before you move on. Okay. So for 21 through 24, we're almost there. So we want to go ahead and simplify the following expression by distributing and combining like terms. Write your final answer in standard form. So basically here we're combining every single thing we just learned. So let's go ahead and figure this out. So right away I see a parentheses here, so I'm going to distribute my 3. So I get 3y squared. Distribute again, plus 3y. Finally, one last time, minus 3, and then this right here, well, I haven't done anything with it, so I'm going to rewrite it down here. I haven't combined anything just yet. That's what I'm actually going to do now. So I have a y squared term here, a y term here, and a y term here, and finally a constant term there. So let's see what we get. Well, the highest one here is a 3y squared. The next one is 3y minus 3y. Well, those basically cancel each other out. So that just leaves me 0. So I'm not going to write anything. But finally, I have my negative 3. So that's your answer for the number 21. All right, I'm going to go ahead and do number 22 with you guys. And then I'm going to have you try out one on your own. Actually, why don't we actually go ahead and do number 23 together. I'm going to let you try number 22 and 24. So if we distribute that out, I get 14n plus 7 times 1 is 7. Do the same thing here, guys. Now be careful. We're distributing a negative 8. So it's negative 8 times 4. That's a negative 32. The negative 8 times negative 3 is a positive 24n. Now I can combine like terms. So I have an n term here and an n term there. Finally, I have 2 constants. Now I can go ahead and combine. 14n plus 24n is a 38n. Positive 7 minus 32 is a minus 25. All right, awesome. So, next one. Go ahead and try it out on your own, guys. All right, so hopefully you were able to distribute these terms out. So let's see what we get. So 3w squared. We didn't do anything, that's why I rewrote it. So then I have this negative 5 times 6w is a negative 30w. Negative 5 times negative 1 is a positive 5. And finally, plus 2w squared. All right, so let's combine some like terms here. I have one like term, two like terms, a negative 3w, and a positive 5. So I have two terms that have a w squared, so that's 3w squared plus 2w squared, that's 5w squared. Then nothing combines with this negative 30, so I'm going to rewrite it, negative 30w. And finally, my constant. That is what you should have gotten. Okay, let's continue. I see right away a parentheses here, so I'm going to distribute. So I'm going to rewrite my 4 because I haven't touched that yet. Now I want to do negative 2 times 3. That's a negative 6x. Now negative 2 times negative 5 is a positive 10. And finally, once again, because I didn't do anything with my 7x, I'm just going to go ahead and rewrite it. So let's see. We have a constant here, and we have a x term here and an x term there. So let's combine that up. So negative 6 plus 7 is a positive 1x. 4 plus 10 is a positive 14. All right. Now, just to clear something up, because a lot of you guys might be doing this, and it's totally fine, because actually that's what I usually do, is I would rewrite this answer here as x plus 14. Oops, sorry about that. X plus 14. Now the reason being is because this coefficient here, that 1, we really don't have to write it down. It's understood that there is a 1 in front of this x here. So if you go ahead and write it like this, x plus 14, you are absolutely right. And if you write it like this, you are also absolutely right. Just I want you to make sure that you understand that you don't have to write that 1 in the front if you have a variable. Okay? Alright guys, so what I want to let you guys off with is this park challenge. Now, if you guys are watching this on your own at home right now, I'm going to go ahead and go over this park challenge with you. Or if you want to know the results of this park challenge answer, actually ask me and I will let you watch the video so you can make sure that you understand how to do it. Okay, but if you are done for the day and you guys are done with this lesson, you can go ahead and turn off the video now and continue working on your homework for chapters 1.1. All right, guys.